So we have discussed various things about sets, and in this continuation we will introduce this intervals as subset of R. What intervals mean? See, if you have say A or B, some numbers or variable you can say which belongs to R, and we say A is less than B. For any set of real numbers, y is such that this y lies between a and b, and we say it is an open interval. Why? Because y is inside a and b, but it is not equal to a and b, right? So we call it as an open interval. We introduce one another thing which is called the closed interval. What is the closed interval? Closed interval is y is of course between a and b, but it can be equal to a and b. Let us take x now. X lies between a and b, that is x is greater than equal to a and less than equal to b, but it may be a, it may be b. How we are going to differentiate it? We'll put a round bracket for this open interval, and we will use this square bracket for the other one, that is the closed interval. But we can have combination of these also, that is the open interval also and closed interval also. For example, x which is greater than equal to a and less than b. So here we'll use the square bracket, and here we'll use the round bracket, and the case can be reversed, that is x is greater than a, x is not including a, so we will use a round bracket, while x is less than equal to b, that is we'll use a square bracket, which means x can be b, x may be b. And what is the actual meaning of this? Meaning of this is, you can see here that sum of the circle you find here is open, that is it is not being filled, while here you find that it is filled. So for this square or for this round we use different notation. Okay, so round bracket, open, and which is not filled we use for this open interval, and for closed interval this is closed, we close it. Okay, for example, see, you say -3 and 5 is a set A, and this definitely lies between -7 and 9. So A is actually a subset of B. But what about it lies inside? So it is lying inside. We are not saying this set as -7, 9, but it is somewhat inside. So it is inside it. This is how we signify it. The other option or other observation is that the length of interval, whether it is a closed or this is a closed one or an open one, or say this combination b minus a, this is called the length of any interval. This is the length of any interval. Now we come to one another important aspect of sets, which is a power set. What is a power set? Power set is nothing but the combination or the collection of all the sets, or you can say the subsets of a set. So if you have a set S, you have a number of subsets S1, S2, S3. You combine this S1, S2, S3, you say this combination of S1, S2, S3 is nothing but the power set. For example, if you have a set say 1, 2, now you want to make the power set of this, and please recall that 5, which is our empty or void or null set, is the subset of each and every set in this world. So what combination or what subsets this 1, 2 have? 5, 1, 2 and 1, 2. So these are 4 of these, 4 subsets of this set. So how many of these are? 4. We say these are the power set of 1, 2. These are the power sets. Let us formalize it now and say that the collection of all the subset of set A is actually the power set of A, which is denoted by P, capital P, and in the bracket the name of the set. So in PA every element is by itself a set. So you see that if A is equal to 1 comma 2 and you want to find a power set of PA, then this is a set and all the component or the element inside this are again these sets. So the combination of set or collection of set or subset of a main set is the power set. So how you got this four entities or four elements? This is actually, you might be aware of the cardinality or NA we have actually introduced earlier. So if NA equal to M, the number of elements here are 2. So just we'll take 2 and the power, that is the M. In this case this is 2. So 2 to the power 2, which is 4. That is why the cardinality of this power set is 4. Next we come to the universal set. Universal set is the universal set, means it is a universe. But let me change what I said. If you are talking about your school, you are talking about your class, you're talking about the teachers, then your school is the universal set, not the universe. So it depends on which set you're talking about. Depending upon that set, a universal set can be. Okay, let me give you an example. This is a Venn diagram. First of all, let me tell you about the Venn diagrams. What is Venn diagram? Venn diagrams are the pictorial representation where you can easily visualize the relationship between different sets and who organized or who presented it. Venn diagram is actually named after English logician, means he was dealing with the logics, and John Venn was this great person's name. And these diagrams, they consist of rectangle, as you can easily observe here, and the circle, or you can say the closed curves. These are circles. So the universal set is represented by this rectangle, as you can visualize here. These are the universal set, and in this Venn diagram the element of the set are written in these respective circles where they belong in the sets. For example, this is just an illustration. What is this illustration? You have seen just the diagram, or see, let us talk about this. First, in this figure you see universal set is what? 1 to 10. All these numbers are universal set, they lie in universal set. But what about A? A is 2, 4, 6, 8, 10. But A consists of 2, 4, 6, 8, 10. So A will contain A 2 to 10. And but this B is inside A, which is 4 and 6. So B will be 4, 6. But the representation, as you can see here, representation is quite clear. That universal set contains A and B, while A set contains B. Okay, this is how we represent it. Now, operations on set. There is a question from my side to you. You might be wondering that can these two sets be added? Can these two sets be multiplied or added or subtracted or divided? Is it possible? As two numbers can be. 5 plus 13 is 18. What about 5 into 13? That will be somewhat 65. But what about set? Can you perform certain operation on a set? And I'll give you a very good news that yes, you can apply these operations on set, though the operations are somewhat different, but these things are possible. Union of set. This corresponds to the addition of two sets plus addition of two sets. So what you do in this union, first of all, union is this U is the sign you use generally for representing the union. So the union means, let me give you an example. First, see this A and B. We will take all the elements of A and place it in the A union B. We will place all the element of B in this A union B, and whichever is duplicated, we'll just keep one. This is union. Again, if we combine these two, see this is a proper subset of A, E, I, U. B is a proper subset of A. So even if you combine them, there will be no change. A will always remain. So A union B will always be A. We are taking all the elements of A. all the elements of B and putting it in the union. So if B is a subset of A, then A union B will always be A. That means if this is B and this is A, if this A is inside, so if you combine A with B, no matter, B is going to be your ultimate answer. Okay. So this is the operation, one of the operation which we just saw. When say in your class 11th, Ram, Gita, Akbar correspond to set X and they are comprising of school hockey team. While Y, that is Geeta, David and Ashok, they are again from your class only, but they comprise of school football team. When you combine them, you say, I want a union of these. When we combine them, you will place all these three, but when we will add Geeta, David, Ashok, you see that Geeta is already there. So you just need to add David and Ashok and you'll find the X union Y. This is how you find the union. So we can define the union of two sets like this. The union of two sets A and B will be some set C which will contain or consist of all the elements either from A or from B. Means you take X, and A and B will contain X, so that X will belong to A or X is going to belong to B. Or, and if you want to represent it using a Venn diagram, this is your Venn diagram. A is this, B is this, and the combination is shown by this shaded area in the blue, and this shaded in the area in the blue is A union B, union. So there are certain properties also of union. A union B is equal to B union A. If you combine A with B or B with A, it doesn't matter. It will be called commutative law. If you take union of A and B and then combine it with C, or you can take A and combine B and C and then combine it with A, this is going to be an associative law and both are going to be same. What about the law of identity element? You know, phi is what? Phi is nothing. Phi is actually the identity of union. So if you combine A with phi, you'll get A. If you combine A with A, means it me with myself, I'll get myself. So that is, this is called idempotent law. If you combine U with A, universal set, with any set, you'll always get a universal set. So this is what we talked about, and in next discussion, we'll be taking a few more aspects like intersection and the complement, etc. So till then, thank you so much. Take care of yourself.